An object with mass m1, which is 5 kilograms, rests on a frictionless horizontal table and is connected to a cable that passes over a pulley and is then fastened to a hanging object with mass m2, which is 10 kilograms. Find the acceleration of each object and the tension in the cable. The first thing we want to do is draw our free body diagram. So here's the horizontal table, and we have a pulley system. Our first mass, which is m1 here, is 5 kilograms. m1. And over here, we have our 10 kilogram block, it's m2. And they're both attached to the same cable over this pulley system. Before we write our forces down, we want to determine which direction is positive for the x and y axis. So I'm going to say that y is positive going downwards and x is positive going to the right. Now we can list our forces. So the only force going in the x direction would be this tension right here. And our forces in the y direction are only going to be on this block. So we have the weight mg, and we also have the tension right here. So if we write sum of forces in the x direction, we would get tension equals mass times acceleration. The reason why tension is positive here is because it's going to the right, which is positive, as we labeled it earlier. For the sum of forces in the y direction, we have positive mg because it's going downward, which we said was positive, and minus t equals ma. So we know that the m for the sum of forces in the x direction will be the 5 kilogram mass because it's the only object going in that direction. So we can say that t equals 5 kilograms times a. Now we can see that we can plug this in to here to find a. So we can rewrite our sum of forces in the y equation, which is mg minus t equals ma. For this t right here, we're gonna write this equation. So mg minus 5 kilograms times a equals ma. And we see that we still have masses here for m's. And because this was derived from the sum of forces in the y equation, we got to look at what mass is moving in the y direction. And we know that this 10 kilogram object is the only object moving in the y direction. So we know that the mass is in fact 10 kilograms. So for here and here, we're going to plug in 10 kilograms. So we write 10 kilograms times g minus 10 kilograms times 9.8 meters per second squared, because we know that's the force due to gravity, minus 5 kilograms times a equals 10 kilograms times a. We can set all the components with a to one side, so we get 98 newtons equals 15a. And now we do some simple division, and we get that the acceleration is 6.53 meters per second squared. And now there's a second part to this question. It's asking us for the tension of the cable. It may seem like there's two tensions, but really they're the same tension. This tension right here and this tension right here are exactly equal. We know this because they're the same exact cable. So what we can do is get the equation that we wrote out earlier right here, So we knew the mass, which is 5 kilograms, and now we know the acceleration, so we can solve for t. So the tension equals mass, which is 5 kilograms, times 6.53 meters per second squared. And now we get tension equals 32.65 newtons.